Temperature dependence of resistivity. See, when we discussed about resistivity, at that time we discussed this thing as temperature increases, resistivity also increases. તમને યાદ હોય તો આપણે એવું ડિસ્કસ કર્યું હતું કે as temperature increases, the kinetic energy associated with the thermal motion of electrons also increases. એટલે ઇલેક્ટ્રોન્સની મોશન સ્પીડી થઈ જાય છે. And due to that, the time between two successive collisions decreases. And rho, that is resistivity, rho, that is m upon any square tau. So rho inversely proportional to tau. Tau, that is the time between two successive collisions. હવે એ જો ઘટે તો resistivity વધે. Okay, no doubt. આ તો આપણે ડિસ્કસ કર્યું કે as temperature increases, resistivity also increases. પણ હવે કેટલું ટેમ્પરેચર વધે તો એને કોરસ્પોન્ડિંગ કેટલી રેઝિસ્ટિવિટીમાં ચેન્જ આવે. તો એ કેલ્ક્યુલેશન કેરી આઉટ કરવું હોય તો આપણી પાસે રેઝિસ્ટિવિટી એન્ડ ટેમ્પરેચર એની રિલેશનશિપ હોવી જોઈએ, રાઈટ? સો the dependence of resistivity on the temperature, that is given by this equation. This is the empirical formula. With the help of large number of experimental observations, this one is prepared. So equation, that is resistivity at any temperature T, rho T, that is equal to resistivity at temperature T0, where T0, that is some reference temperature, into 1 plus alpha into T minus T0, where alpha, that is known as the temperature coefficient of resistivity, and that will be given to you because it is different for different materials, and in text a table for alpha for different materials that is given to you. Okay, so here one can calculate the resistivity at a particular temperature T using this equation. Now the same type of equation we can write for resistance also. We know when resistivity increases, resistance that will also increase with temperature. Now resistivity rho, that is RA by L. So we can write here R at any temperature T, area of cross section of the conductor upon length of the conductor. So at temperature T or T0, area and length, that is constant one. Okay, so we can write R at temperature T into A upon L, that is equal to R at temperature T0 into A by L into bracket 1 plus alpha T minus T0. Okay, so A by L cancelled. So we can write resistance at any temperature T, that is equal to resistance at any reference temperature T0 into 1 plus alpha T minus T0. Clear to all of you? Now for different materials, how the resistivity changes with temperature, that is given to you. Suppose we think about the metals. Here the example of copper that is given to you. So graph of resistivity versus temperature that is given to you. And here we can observe this thing. As temperature increases, then initially the resistivity increases very slowly up to 50 Kelvin. But after 50 Kelvin, with temperature, the increase in the resistivity that is considerable one. Okay. Now, here you can observe this thing. See, above 50, non-linearly the resistivity increases. Means as the higher temperature we take, resistivity increases rapidly. Clear to all of you? Then after, if we think about the alloys, then we can say this thing, the resistivity of alloys that is almost independent of temperature. See here, one example is given to you, the relationship of resistivity of nichrome as a function of temperature, that is given to you. See, resistivity that is in terms of micro ohm centimeter. Micro ohm. Micro stands for 10 is to minus 6. Okay. Now see here, at 0 Kelvin, the resistivity that is this much. Then here at 800, the resistivity that is almost up to this one. So roughly you can observe this thing, when here the change in the temperature that is up to 800 Kelvin. Change in temperature that is 800 Kelvin, and corresponding to that the change here in resistivity. If we take this one nearly 1, then 1 micro ohm. So 10 raised to minus 6 ohm centimeter. This much small variation takes place. So we can say at room temperature, in laboratory, when we perform the simple experiments, at that time we can consider the resistivity of alloys that is almost independent of temperature. Clear to all of you, beta? Then after, for semiconductors, so the graph of the resistivity versus temperature for the semiconductors, that represent this thing. For semiconductor, as the temperature increases, resistivity decreases. Or in other words, we can say for semiconductors, with increase in the temperature, its conductivity increases. And why this happens, that we will discuss in detail in chapter number 14. Clear?